Alright, so now that we've looked at what the mean of the sample mean will be and what its standard deviation is, let's have a look at some examples. So first we'll look at number 1. Sulfur compounds such as dimethyl sulfide, or DMS, are sometimes present in wines. DMS causes off odors in wine, so winemakers want to know the odor threshold, which is the lowest concentration of DMS that the human nose can detect. Extensive studies have found DMS odor threshold of adults follow a roughly normal distribution, with mu equals 25 micrograms per liter and sigma equals 7. Suppose we take an SRS of 10 adults and determine the mean odor threshold X bar for the individuals in the sample. So what is the mean of the sampling distribution, and explain. So from what we've learned already, the mean of the sample distribution is the same as the mean of the population, which is 25 micrograms. And it just happens that mu is the symbol for micro as well, micrograms per liter. And why is that the mean? Because it is an unbiased estimator of mu. So B, what is the standard deviation of the sampling distribution? Well, before we can actually go and calculate this, we do still need to check for independence. So make sure when you're answering questions that you are doing this check. N must be less than or equal to 1/10 of the population size. So it is reasonable to assume that there are, in this case, n would have to be, if we rearrange this, n would have to be greater than or equal to 100. And it is reasonable to assume that there are more than 100 adults in the population. Okay, so now we can go ahead and use our formula. Sigma x bar equals sigma over the square root of n. And so this is equal to 7 over the square root of 10, which is 2.21. Now both of these formulas are on the formula sheet, so you do not need to memorize them. How would you decrease the standard deviation by a factor of 1/3? So in this case, we would have to increase the sample size by a factor of 9, which would give us 90 adults. Now, why would it be 9? Well, if you recall, we're dividing by the square root of n, so we need to have 3 squared. Okay, let's look at another example. For sampling distributions of a sample mean from a normal distribution. So suppose a population is normally distributed with the mean and standard deviation is given. The standard sampling distribution has the normal distribution with the mean, mu, and the standard deviation of sigma over the square root of n, provided that the 10% condition is met. So, example 2, the length of human pregnancies from conception to birth varies according to a distribution that is approximately normal with mean 266 days and standard deviation 16 days. Find the probability that a randomly chosen woman has a pregnancy that lasts for more than 270 days. Alright, so it'd be good for you to try this on your own before you come back and see the solution. So pause now. Alright, so x, we're going to let x be a random variable for the length of pregnancy. So we're going to do state, plan, do, and conclude. So first of all, state. We're looking for Px being greater than or equal to 270. Plan. Well, we do need to check that, we're going to assume here that that it meets the 10% condition because the population is very large, so we're not going to add anything to there. For do, we need to draw our sketch. We've got a normal distribution. The mean is 266, and we're looking at the probability that it's greater than 270, so the shaded area. We can use normal CDF, normal cumulative distribution function. We want starting at 270, going to infinity. Our mean is 266, and our sigma is 16. Okay. Now this is based on simply what's the probability from our given data of our population. So we end up with 0.401, and then conclude there is an approximately 40% chance a random pregnancy will exceed 270 days. So what is the mean of the sampling distribution of X bar? So in this case, we need to add a little bit that I'm going to sample 6 pregnant women. So our expected, the mean of our sampling distribution X bar is going to be, and you should already have guessed this, 266 days, because the mean of X bar is an unbiased estimator of population mean. So calculating the standard deviation of this sampling distribution, we need to check for independence first. So 6 is less than or equal to 1 over 10 n. So the population would have to be greater than or equal to 60. And so it is reasonable to assume there are more than 60 pregnant women in our population. So therefore we can use our equation for standard deviation. 16 is the standard deviation of the population, and we're taking the square root of 6, so we get 6.53, and that's our answer for that question. Okay, so let's look at part D. It says find the probability of that the mean pregnancy length for women in the sample So in this case, we're looking at in the sample, exceeds 270 days. So once again, we'll draw a sketch. Our mean for our sample is 266. Once again, we're looking at 270 onwards. And what changes this time is our standard deviation. Normal CDF, 270 to infinity. The mean is 266, but our standard deviation has switched to 6.53. So now we get 0.27. And our conclusion is the probability that the mean pregnancy length in our sample, so that's the key, exceeds so the probability that the mean pregnancy length in our sample exceeds 270 days is 27%. Okay, so that, as you can see, is different. For the total population, the probability that a randomly chosen woman has a pregnancy over 27 days was 40%. That the mean of our sample is over 270 is only 27%. So we're looking at two different things here.